So for our first question, we want to find f prime and f double prime of the function f of x equals 5x cubed minus 6 divided by x squared. So our first step is we want to go ahead and simplify the function. So f of x equals 5x cubed divided by x squared minus 6 divided by x squared. So 5x cubed divided by x squared, that's going to give us 5x, and then using the exponent rule, we can go ahead and bring our x squared into the numerator, but that's going to change it into negative 6x to the power of negative 2. Now we can go ahead and find a derivative of both terms. So we're going to go ahead and use the power rule. The x has an exponent of 1, so we're going to have 1 times 5x to the power of 1 minus 1, and that's going to give us 5x to the power of 0. Anything to the power of 0 is 1, so that's going to simplify to 5 times 1, which is 5. Now we're going to find the derivative of the second term, which is negative 6x to the power of negative 2. We're going to have negative 2 times negative 6x to the power of negative 2 minus 1. Negative 2 times negative 6 is positive 12x, and then we have negative 2 minus 1, which is negative 3. So if we put that together, we're going to have f prime of x equals 5 plus 12x to the power of negative 3, which is going to be our answer. Now, in order to find f prime of x, we are going to get the derivative of 5 plus 12x to the power of negative 3 again. So what that is going to look like is the derivative of a constant 5 is 0. And so we're going to find the derivative of the next term, which is 12x to the power of negative 3. And we're going to use the power rule again. So that's going to be negative 3 times 12x to the power of negative 3 minus 1, which is going to give us negative 36x to the power of negative 4, which is going to be our answer for f double prime of x. Second question, we're going to determine the area of the region bounded by the function, the x-axis, and the vertical lines x equals 3 and x equals 4. The region lies above the x-axis. So what this question is asking us is it wants us to find the area underneath a curve from x equals 3 and x equals 4 of the function f of x equals e to the power of negative x plus 3. So knowing this information, we can go ahead and write the area A equals the integral 3 to 4 of e to the power of negative x plus 3 times dx. So looking at our exponent, because it is an expression, it is easier to use substitution instead. So we're going to have u equals negative x plus 3. We're going to differentiate both sides, and that's going to give us du over dx equals the derivative of negative x plus 3 is negative 1. We're going to go ahead and multiply dx on both sides, and that's going to give us du equals negative dx. We can go ahead and divide out that negative 1 to get negative du equals dx. Alright, so also we know that this is a definite integral. We can change the limits of integration. And so in order to do that, we're going to substitute when x equals 3 and x equals 4 into this expression. So when x equals 3, we have u equals negative 3 plus 3, which equals 0. When x equals 4, we have u equals -4 plus 3, which equals -1. So now we can go ahead and rewrite the entire integral in terms of u, which would look like the integral of 0 to -1 of e to the power of u times, instead of dx, we're going to go ahead and replace that with negative du. This negative can go outside of our sign, so we can go ahead and rewrite that. So it's going to be negative integral of 0 to -1 of e to the power of u times du. Okay, so now we can go ahead and continue evaluating it. So the antiderivative of EU is still EU, so we will get e to the power of u evaluated from -1 to 0. So all that is saying is we're going to substitute the upper limit and then subtract it from the lower limit. So that's going to be e to the power of 0 minus e to the power of 1. Anything to the power of 0 is still 1. So that's going to change. Oh, sorry, this is a -1. That's going to change into 1 minus e to the power of -1. And then we can go ahead and rewrite that using the exponent rule of 1 minus 1 to the power, 1 over e to the power of -1 as our answer. And if you go ahead and plug this into the calculator, you're going to get around 0.632.